So moving on to our next speaker, I'm very excited to introduce to you Kristian Kloeckl. He told me to pull in my cheeks when I said that, Kloeckl. Kristian leads the Real-Time City Initiative at the MIT Sensible City Lab in Boston and Singapore, and teaches at MIT as well the IUAV University of Venice. A trained industrial designer, he has conducted his studies in Austria, Italy, and the UK, and holds a PhD in design sciences. Kristian has worked with Antonio Ciderio in Milan, as well as consulted with companies in Italy and Austria on industrial design and design strategies. Kristian and I had some really interesting conversation early this morning with our cup of coffee about the intersection of industrial design and architecture. So it's very clear to me that Kristian is a critical thinker, and I'm sure our dialogue will continue. His work is guided by an interest in how to give form to technological innovation and create meaningful connections between people, objects, space, and the digital data layers that pervade our cities. His projects have been exhibited at the MoMA in 2008, the Venice Architecture Biennale in 2008, the Vienna MIK in 2009, and the Singapore Art Museum in 2011, as well the China Millennium Monument Design of Digital Arts in 2012. So his work is well received. So let's all welcome Kristian Kloeckl.
Okay, good morning. So I'll give you a brief presentation this morning on a project that we're carrying out at the Sensible City Lab at MIT, as well as in Singapore. And I'd like to give you a brief introduction about what we do at the Sensible City Lab, just to tell you about where we are coming from what angle. If you think back the 1990s, think back, there was this explosion of digital technologies, digital telecommunication technologies. We really thought we'd telecommute everywhere. You remember? We thought we wouldn't travel to cities anymore, we'd live in the countryside, we wouldn't be here for conferences, but you'd all be connecting through telecommunications, and that was not very long ago, and we were very convinced of that. Even people like George Gilder announced that that would be the death of cities. Cities would be leftover baggage of the industrial era. We wouldn't need them anymore. And that was very recently, and today we see it's not happened. Cities, especially large cities, are thriving more than ever. Just in 2008, the threshold was passed of more than half the world's population living in cities, with this being a trend that is still continuing and projected to grow. So cities are becoming ever more important. People are moving to cities, and that's part of what we're interested in at the Sensible City Lab. Working at the intersection between urban studies and digital technologies, we're particularly interested by the fact that increasingly our cities generate enormous amounts of data every time as we speak. Think about when you take public transport using a smart card electronic ticket. Data is being generated as a function of you taking this trip. Think about when we use any such device or just have it in our pocket. These devices connect constantly to the network to tell the network where the device is. Not for anything but to keep this network functioning and keep calls connecting to your phone. Think about things such as urban environmental sensor networks. We've heard a lot about river systems before, water level sensors and other sensor networks that are constantly connected, constantly generating data that describe our environment. Think about payment methods, credit cards, ATMs. Increasingly, as we move through life, following whatever routine we follow, we generate what we could call digital traces behind us. Digital data that are a function of our behavior, of activities in urban space. And so at the juncture of urban studies and these technologies, we're interested at Sensible City Lab at exploring new connections between these increasing layers of digital data that's being created on a pervasive level in our cities, and the physical environment that we live in, and that, from what I showed you before, we clearly want to live in as well. So how can we create these connections? Concretely, we're interested in collaborating with network operators, systems operators of telecommunication networks, cell phone networks, operators of sensor networks, transportation companies, whose networks generate data as a function of its operations. That's a sort of side product. Huh? If you consider smart card electronic tickets for public transport, well, their main purpose is to let you get on a bus and show that you've got a ticket. But think of this being generated for millions of passengers in real time. This becomes a really interesting source to understanding in real time how cities work, how people make use of space, and we are interested in developing technologies and understanding how we can use this in a design process, in a planning process, in a management process of cities and city environments, how we can use this to better understand cities and to provide this data back as information for decision-making processes. As part of our projects, I'll be telling you some more about the Live Singapore project. We've been working in Singapore over the last 2.5 years. As a lab, we often partner with industry partners, but also with cities. Copenhagen is another partner city of ours. We've worked with Seattle, in New York, as well as Rome, to mention some other cities. And a few years ago in Rome, we've set up a first project working with real-time data of urban systems, which we brought together real-time data from the cell phone network in the city of Rome, together with public transport data, to create visual analytics such as these ones, overlaying the density of the population in urban space, that would be the red clouds, inferred from the cell phone network data, overlaying this with public transport, location of buses, which leads you to questions such as whether buses are where the people are at any given time. But then it can really become the basis to take this forward, thinking of how buses could perhaps dynamically adapt their routes according to upcoming demand areas, or in the end, how could buses run after people as opposed to people running after buses? Even that might be a scary perspective. We've showcased some of this visual analytics where we really focus on the technologies to enable the work with this real-time data, as well as the interface to make this data graspable, accessible, understanding fully meaningful ways to planners and designers. At the Venice Architecture Biennial a few years ago, creating visualizations, dynamic visualizations that were driven by this real-time data. And in the following year, we've taken this a step forward, really trying to see how we could turn this data in cities into a tool for people to move through their city based on the information about what's actually happening in their city. And so we used a large 10 by 5 meter public projection in the center of Rome during a large-scale public event, which is the Long Night of Museums. It was a huge event, 2 million people participating all through the night, 400 different events all over town, and providing people with information about where is it that people are gathering, where is it that public transport's coming by, which events are starting where, allowing people to live the city experience in a more dynamic and ad hoc way as they go through this urban context. Now, this past work is one of the inspirations for our Singapore project. The other one is recent projects in the open data dimension, especially in the States where this started by the Obama administration and the data.gov initiative, which since then has branched out and been replicated in other countries. Competitions have been organized in which governments open up data that different agencies are collecting, allowing developers, creative minds to use this data to develop new applications for citizens. Live Singapore in this line focuses on an open platform development for data in an urban context, but not so much historic data as much as real-time data that's generated by urban systems and networks. With the ultimate goal of us being really to creating this sort of feedback loop between activities and actions that are happening in a city, urban dynamics as they happen, data that's being generated as a function of them, and how to provide this information concealed in the data back to people when they're taking decisions about what activities to follow. That leads to transportation, for example. Think when you're deciding to take that car to drive to the store to get a product, and you drive there just to find out that the product's out of stock. Well, the information that the product was out of stock in that store probably exists in one of the many data systems that there are. It's just that you didn't have access to that information. Had you had access, you wouldn't have had to take the car, drive that, create transportation, emissions, consume energy, and so forth. Otherwise, how often has it happened that you rush to a bus stop just then to wait there for 10, 15 minutes? Well, that information is available. Increasingly, it's possible to work this information on an urban scale. When I talk about transportation, it becomes clear that this is not only about transportation-related data, because as soon as you think that most of the times there's a purpose to why people move, you immediately get to other spheres of interesting data sources to work with, such as services, product availability, events, data related to social relations, friends, and family. On the one side. On the other hand, people move within a context, an environmental context, a personal context. And so also data linked to these two spheres is of interest to the project. The three large groups of data sources that we're trying to work with and to develop tools for to work with an urban context refer to existing data infrastructures and systems, telecommunication system, transportation system that generate data already as a sort of side product, dedicated sensor networks, as well as user-generated data. With these data types, we focus in this project on the data collection, the combination, and the distribution, by which distribution, I mean largely visualization and what you call tangibilization of data, really creating meaningful ways that provides people, expert users, non-expert users, access to information concealed in this data that's meaningful to whatever activities they're pursuing. Why Singapore? Well, Singapore is a very interesting context for those of you who've been there. It's a city-state. So there's a city, which is a state, which is an island, about 50 by 30 kilometers in dimension. It's very compact, only 2 bridges that connect Singapore to the Malaysian mainland across the thin Singapore Straits. And it's a highly developed, it's a city with a highly developed infrastructure, very tech-savvy population, and a population that's used to a city in constant change. The city is now one of the most developed cities probably on the globe and has become so only over the last 40, 50 years. It's had a very rapid development. Now, on the technology side, we work with cities, and so we like to iteratively share with the city some of the pilot projects based on the technologies that we developed. And so last year at the Singapore Art Museum, we shared with the Singapore public a series of dynamic real-time data visualizations driven by real-time data from the city to provide people a new perspective on their city through the eyes of data. In this way, and I'll tell you something more about how we set up the whole project, we've worked together with a series of institutions and companies in Singapore, such as the airport, Changi Airport, the local taxi company, which operates 16,000 taxis in Singapore. So it's a huge amount of vehicles to drive through the road. And since you're all planners and architects here, you realize that having 16,000 taxis in a city, 50 by 30 kilometers, each of these taxis having GPS, which sends information back about the speed of the car, the location, the status of occupancy. That's a really interesting data source to work with, because it's like having probes, GPS probes, in the traffic stream that give you very interesting insights into how traffic works overall. Other data we worked with is the electricity consumption of the city with the electricity company, the National Environmental Agency, the port, which is the largest transshipment port in the world, as well as the cell phone network operator and electricity company, creating in this exhibition a series of visualizations, some of which people could engage with at this quite beautiful Singapore Art Museum. And there's a series of visualizations I'll talk you briefly through now and show you in a brief video afterwards. But just to tell you about what they are so that you can see what they're about. The first one's looking at cell phone network data to infer population distribution in real time. That was working with a real-time data stream from that company, allowing you to understand where are people in any time of the day. Very interesting to look at in conjunction with mobility, with emergency situations, evacuation situations, and others. Next was looking at electricity consumption throughout the island in conjunction with wind speed to get the first hint about potential local temperature increases generated by energy consumption. Energy consumption generates heat on a local scale, small scale. Wind dissipates then. Next visualization is Formula One City, how a large-scale event such as the Formula One Grand Prix, which in Singapore is right in a city center. It's really cutting off a series of roads in the city center for several weeks for this event, looking at cell phone network data again on a normal day, you see on the left, during the race day on the right, just to understand how this totally changes the context and the dynamics of the city, which is very interesting to understand in order to handle such a situation. The next one, very specific to a tropical context of Singapore. Rain has a huge impact on transportation. In a tropical context where it rains a lot, pretty much every day, it rains for a very short time, rains very intensely, you don't see the other side of the road. And the strange thing, for me at least, was that it rains in small, very small geographic pockets. It might rain here and not a mile from here. So that was interesting to look at how just to combining these different data sources, where taxis are and where rain is coming up, to provide information about where high upcoming demand areas for taxis are. Taxis in Singapore cost about a third from here, so they're much more part of the overall transportation system. It's very much a transport on demand system nearly because of the much lower price. And the last, second last visualization took these taxis as probes for the overall transportation system, understanding how long it would take you to travel from any one place of the city to any other place of the city, and converting this information into an isochronic map by which the distance gets longer physically, the longer time you have to travel to get from one place to the other. And so a slow traffic increases the city side, fast traffic reduces the city side. And the last one focuses on Singapore as a hub, both in terms of passenger transportation as well as container transportations, a hub of people traveling in and out of the country, as well as material flowing in and out of the country. And that's a brief summary of these visualizations. So this was one of the urban demos, as we call them, that we organized last year. The Live Singapore project is really a platform project, however. It's not about any one specific application or dealing with one or a certain number of specific data types, but it's really about exploring and developing technologies that allows us to harness the richness and the wealth of data that's being generated in our context. Coming myself from the design side, I increasingly see this data really like a new material to work with when you're designing objects, services, infrastructure, spaces in city. Because this data exists, it's generated everywhere, and as soon as you open or integrate into your buildings, into your environment, sensors, and be it as simple as door sensors, environmental sensors, water quality sensors, air quality sensors, wind measure sensors, if you think about what you can do with this data at the outset of planning, you can really very carefully position these in much better way, allowing other things to be created with the resulting data that's being generated. So that's why I think it's really important and interesting to consider what can be done with data streams at the end, at the very beginning when you're planning projects. A subsequent project we did, and that was interesting as a consequence of this project, we showcased this in Singapore, and the Land Transport Authority came to the opening and said, why we are not on the map? And so they joined as partner of the project and provided us with some very interesting data streams related to public transport system and road transport. Public transport in Singapore is interesting in terms of that with the smart card ticket, you tap in and you tap out also on buses as you do in subways in most cities. So the data that's being generated is a very complete set of data of origin destinations. For all trips, regardless of whether a subway or a bus, or other means, you've got origin destination, which becomes a very powerful way for the transport authority to plan the transport network. We've worked with them on how to make data accessible to users and how to use this data, since it's often surprisingly little used within such organizations themselves, let alone making this accessible to users to provide interesting new services or new information of how to access this service. We've developed 3 visual analytic applications, one touching bus rides, data lenses, and traffic engines, traffic origins. I'd like to show brief videos for the first 2 of them, the first one being touching bus rides.
With over 2 million riders a day, Singapore's bus network is an integral part of the island's transportation system. Here, we visualize bus passengers and bus rides in Singapore using a multi-touch table. A selected bus line is shown with boarding and alighting passengers at each stop. Zoom and pan to areas of interest and tap to get detailed information. The map view allows different urban areas and clusters of bus stops to be compared. You can see many passengers boarding in dwelling areas and alighting in the city center. Various bus lines can be displayed and compared, with inbound and outbound passengers shown for a specific time range. Users can change the time using the time slider and switch between morning and evening rush hours. Every interaction is instantly reflected in the visualization. Users can also display multiple charts of the same bus line in time series. Each row shows all bus stops at different times of day. Adapt the time range in the histogram to alter the time frame. One sequence for every hour is displayed, with some stops showing strong temporal variations. The gap between circles represents the actual distance between the bus stops. A third visualization shows rides between bus stops. Each arc represents the number of passengers traveling from one stop to another. The 3 visualization modes provide different perspectives on the dataset, while the fluid interactivity gives a unified user experience. Together, they provide users with visual and tangible access to public transit networks, disseminating vital knowledge of the city's dynamics.
So in this regard, while it might not become evident from seeing this, there are immediately a series of concrete applications that can be extracted from this, which in fact we're talking about. One of a series of examples that I'd like to mention here is bus bunching. That's a phenomenon where you have got basically 2 buses of the same line in very short intervals, which is generally seen as something negative because the second bus tends to be empty, just following and trailing the first bus. So bus companies and transport organizations generally have a hard time avoiding that, if not working with such data. Now, the interesting thing is that with this sort of data that we've been working here, where you actually have all the tap-ins and tap-outs, you can actually know how many people are on any bus at any given time. So besides being able to provide information to riders at the bus stop about that the next bus, yes, might be coming in 5 minutes, but it's actually full. So the following bus, which arrives in 15, is only half full, which might enable some people to take a coffee instead of waiting at a bus stop, which is a huge thing for the bus company because it alleviates the system pressure and allows a transportation company for the first time to work on the demand side of transportation as opposed to the supply side in a dynamic way. Usually it's always more buses, larger buses in rush hour, but when you can provide this information about the system load to travelers, you might be able to actually work on the demand shaping side of things. Bus bunching in this way can be used in a creative way to actually create bus bunching in case of an overflow of the system. When there are too many filled up buses, you can have other buses travel very, very soon behind in an organized way. Another application links to the arcs you saw between the different bus stops. Typically, express lines in bus systems are set up in static ways at specific times of the day, specific days, between specific stations. Being able to see in real time how travel patterns form between specific bus stops allows bus companies, in this case, to set up express lines quite dynamically following demand patterns and transport patterns. Another application that might be interesting for planners is that typically we have bus lanes on streets that are organized in static ways. They're either physical structures divided from the rest of the road, or they're organized in specific times of the day, on, off. In this way, we looked at combinations of data that allows us to see, and that's data that exists in several cities, about where are most people trapped in slow traffic that are on public transport buses. That's a very interesting new perspective of going about alleviating traffic jams, when you see how do traffic jams impact people in buses, actually. And that might lead to opening up bus lanes dynamically wherever there's a demand because of buses being stuck. Next visual application that we developed is called data lenses. That's trying to dig through the wealth of information that can be extracted from a few of these data sources by a visual tool that we developed, and that's a short video again.
With data provided by the Land Transport Authority, it is possible to monitor the activity of buses throughout Singapore. But, considering the large volume of information, exploring individual bus stops is a challenge for visualization. In order to achieve this, an interactive tool has been developed. It acts like a magnifying glass, allowing you to explore with great detail the activity of the bus network in Singapore. This magnifying glass distorts points in space to accommodate great zoom levels. It permits local browsing of the space, maintaining its continuity and emphasizing other distinctive points in the periphery. The lens can be dragged over the bus network of Singapore or focused on a spatially restricted set of bus stops. Several properties of the lens can be modified, like the radius or the magnification level. The lens can filter several types of information, like the line number of buses currently stationary at each bus stop, the number of passengers on any one bus, and the total fares paid by passengers alighting at that stop. One can rapidly switch between these applications and explore different features of the transit system. Designed to visualize real-time data, it also currently supports both real-time and 1,000 times the real-time visualization speed, enabling users to discover the spatio-temporal patterns of Singapore's bus network.
Focusing then somewhat more on the incidents and road transportation, we worked somewhat with data generated by the road authority, the transport authority, linked to automobile transportation. And that's a short video that documents that third application that we developed for this.
Road accidents are daily problems for cities, causing disruption, delays, and congestion. But how exactly does this occur? Road speed and traffic flow data derived from Singapore's Land Transport Authority were combined with information about the location and timing of traffic accidents. Here, we are able to explore the dynamics of this disruptive behavior. Pink circles identify accidents, blue, heavy traffic, and orange, vehicle breakdowns. This data can be fed into simulation models that allow us to better understand and predict how such disruptions impact network performance, better respond to traffic incidents, and design more robust road networks.
So these three visualizations form the group that we developed to really work with data in the mobility sphere and make this data accessible to expert and non-expert users in new ways, to really consider this in their planning and management process. What was interesting to see was how working with data becomes also a form of mediating between different disciplinary groups and organizations within a city. Since when you bring data streams together, really you create a very powerful platform for people to meet. Recently I saw a great example of this in Rio de Janeiro, where IBM, together with the city of Rio de Janeiro, has set up what they call a control center. So it's got a big screen with all information on that screen, like we'd imagine from some of the 70s science fiction movies. Now, every control center needs to have this big screen. But then really the interesting thing is that there's people in this room. And talking with the director of that center, it was interesting to learn that basically because of that control room, what they enabled and required was that bringing together different information and data streams from different organizations, transport organization, environmental organization, electricity, waste collection, and so forth, they had one person 24 hours a day from each of these organizations present in that room, since they consider it a room for emergency relief. And that's really been the first time that at any given time, one person of all these organizations was together in one room, being able to discuss issues that brought them forward also in terms of collaboration between these organizations. So it's interesting also to look at data as a form that enables collaboration between different organizations, different disciplines within an urban context. And in this way, the project I've showed you so far, Live Singapore, became a catalyzer for what is now turning into Changi Now. Having worked with data of the taxi company and the airport, it became clear very soon to us that this is one of the intermodal transport connectors that's often overlooked. And in Singapore, you've got a lot of passengers arriving. Changi Airport is one of the main hubs in the region, and you've got lots of taxis going to the airport to pick up these passengers. 16,000 taxis all over the city. Going to the airport is the most lucrative business for these taxi drivers, as in many cities. One system knows very little about the other system. In terms of taxi drivers, create this main nuisance always to the airport, because in order to know when the flights are actually arriving that are often delayed, as many airports, they call the airport's helpline, filling up the helpline with calls. As well as the airport doesn't really know how many taxis are waiting where. But in both systems, there's data being generated, not only about when flights arrive, but how many people arrive on these flights and from where they arrive. And looking at historical information in this, you can actually know quite well how many of these people arriving from different locations are most likely to take a taxi. On the other hand, taxi information, as we've seen before, is very complete in terms of GPS location, status location. So there's information about how many taxis are waiting and where they are, whether they're available, whether they're in reach somewhere. And there's information available about how many people literally are arriving and when they're arriving in real time. So bringing this information together is now a project that's received a startup fund in Singapore, a project we call Changi Now, which is bringing together these two different bits of information, creating a system which potentially is much more efficient, keeping taxis from driving to the airport and staying there in queues for 3, often 4 hours, creating a drain of transport opportunity in the rest of the city, and on the other hand, avoiding that passengers arrive not finding any taxis, so creating a better match. And that's a very good illustration of generally a lot of opportunities that arise when you deal with real-time data as a form of city management to create better matches between demand and supply sides in various contexts. Another thing we did with data in Singapore, and Singapore is an example here, but really it's about creatively thinking about one's own context, how to use data that is being generated in our cities, and for what purposes this can be used. It might not be the tropical rainfalls that are of interest to us in places like Boston, Philadelphia, but other areas and other interesting domains to look at. What's interesting to us is also look at data not in the most straightforward way. One way to look at data is, say, work with transportation data for transportation purposes. Work with electricity consumption, energy consumption data for energy-saving purposes. That's a straightforward way of working with data. But often, working with data creatively allows you to do what we call opportunistic sensing, to use some data that's generated in one system for insights in a very different domain. And one example I'd like to give you here relates to what we did in the domain of acceleration mapping in Singapore. I mentioned before, taxi systems in our cities generate a very interesting source of data on the location of these taxis, the speed of these taxis. So when you've got a very high number of these managed fleet vehicles in a city that reports this information at high frequencies, such in this case, you get a very good indicator not only of the speed of these vehicles and the speed of the traffic flow overall, considering them as probes, but you get something else. You get insight into where accelerations happen. And that is very interesting because it is where accelerations happen that most emissions are being generated. Emissions are not so much generated where cars travel at high speed. It's more the stop-and-go behavior. And there is a direct link again to the planning and the design of urban context. Where does stop-and-go behavior happen? And then there are several reasons why it happens. It might be because of traffic lights being set in a certain order, parking behavior, and so forth. So looking at this data source from taxis, we were interested in looking at where does acceleration happen in Singapore. We calculated that then to create an acceleration map, extracting the data samples that were useful for this purpose, splitting the city in squares, and then gradually aggregating these accelerations by locations, and identifying what we'd call some of the hotspots in this. This is the city, a large part of the city of Singapore. That's the acceleration map that we came up with, and in the end brought us to the top 10 acceleration spots over a 5-week period. They were fairly consistent, so that indicated a good robustness of the approach that we had. And looking, concretely at where they are brings you to some intersections. And that sort of information is huge for cities because cities are really interested to understanding where is the hot spots to work with, where are the worst areas of emission concentrations, and then figure out what we can do about it. But first, understanding where the hotspots to work on is really interesting. These are the 2 top intersections. I figured out in this way is that when I stay in Singapore, I stay very close to one of them. I'm going to change that now. And subsequently, we said, well, let's go out and measure the air quality at these intersections. And so that's something that's currently in progress. These are 2 of my colleagues here, Rex Britt on the right, who is on this project as well, manually equipped with air quality sensors, finding out whether there's this correlation, to what extent we can use this source of data for insights into where acceleration happens, where emissions are being generated, in order to use this then for planning and city management purposes. I'd like to also talk a bit about how such projects come about. We've been working over the last years in several cities with data and enabling the use of data in cities. That's focusing on transportation data, it's focusing on sensor data, that's focusing on data from buildings as well, the energy usage of buildings. Currently, there's a project ongoing. We're using the MIT campus a bit as a test bed to see how much energy is consumed in buildings for heating, for air conditioning, for lighting. And we're using data from the Wi-Fi network. MIT students and people are always online connected, so you can figure out pretty well whether there are people in different spaces by looking at the network connectivity data and bringing this information together again, getting a better understanding of how does the energy consumption of building change in regards to whether people are occupying space at all. And actually, dramatically, we found that to some extent there's more energy consumed in spaces with less people, particularly during colder times of the year, because if there's less people in a room and you need to heat this room up, it'll require actually more heat to heat up that room. So ironically, often it happens that there's less people in a room and more energy being consumed to heat up the room to maintain it at the same temperature. Setting up these projects is quite interesting also, and becomes a quite organic process, bring together different operators. That's a project map I've set up, and that's gradually evolving, in which this first jump forward to a Live Singapore at SAM exhibition is interesting for designers and planners, I think. Our group is very much doing design-based research and research-based design. So our projects are really formulated around a shared design vision. How do we imagine cities to be? How do we imagine things to happen in cities today, tomorrow, in order to then articulate what technologies we want to employ, what technologies we want to develop to enable this. And so it's formulating this design vision that allows us to draw in and connect with different partners and operators throughout the city because they understand the shared objective. Then at the same time, working with this data really alters the project dynamically. Since before you work with the data, it's really hard to understand what you can do with the data. And that is always a chicken and an egg problem we often face in projects because we approach partners, industry partners, network operators, agencies to share data with us, to do analytics with it and use in our research projects. And these partners often would like to understand beforehand what we're going to do with that data, which is frankly impossible because as long as you don't know what is in the data, what patterns emerge once you analyze it, you can't really say what you're going to do. So it's really an iterative process that you go through. This project then gradually emerged, and as I mentioned, showcasing the first step with this digital map was really interesting because other agencies and companies were struck by that and thought, well, we want to be on this map. It became clear that this digital real-time map suddenly is a map which describes the city in new ways to people in urban space, and people wanted to be part of that. And so I think this is also something that can be used in creative ways to move forward such initiatives. Gradually, then the project branched out and involved also EDB, which is a very interesting agency in Singapore Economic Development Board. One of the key factors probably of Singapore's stellar economic growth over the past 40, 50 years. It's really like having a consulting company within the government as a government agency. Very interesting structure, and they've approached us because they thought that's interesting, because if we bring together all this data that's generated by our cities, it's basically mining a resource that already exists, but bring it together and develop technologies so that developers, designers, planners can share it, can use it for their projects. That might be interesting new business models and might become new basis and new ecosystem for economic development to happen as well. And so they came on board as well, and together with them, we're trying to understand what structures, what policy structures and consortium structures would best support this bringing together data sources. Because working with data, and that's been very interesting also, involves a series of policy questions on city levels, on national levels, that are relevant to developing any urban real-time data platform. And increasingly having engaged with policymakers in various cities, some of them, I think, have become more urgent, and they're still being debated, but it's good to debate them at the very beginning of when technologies are being developed, because technologies are never neutral, I think. They always come with values, and so better to understand what values you want to provide them with. One first question is how to create an incentive structure, I think. How do you create a system or a setup or a dynamic so that people want to join and participate? Why would you, some of you probably are involved with organizations that generate data, have sensor networks or have been involved with projects where there are sensor networks. Think of the transportation companies, sensor networks. Why would any such organization share its data with other organizations or even share it openly so that other people could bring together different data types? How can you set up such an incentive structure that it becomes clear where the benefit is also in individuals? And that's one first step. The second step that I think is critical is who runs such a platform. If you talk about bringing data together, who runs this platform and who owns the platform? Is it a public institution? Is it a private institution? Is it an academic institution? Is it a newly set up neutral institution? Who runs this becomes very important. A third step which involves all of us is who owns that data. We talk about cell phone network data that's generated by systems. Who owns that data? Is it the network operator that owns the data? Is that a public good that we should consider that should be shared anonymously and in aggregated ways, which is always the constraint in which we work as well? Or is it owned by people? Is it owned by you when you make a cell phone call and data is being generated? Are you the owners of that data? There have been several interesting cases in Europe recently, one of them being in Germany, where a parliamentarian from the Green Party requested the German telecom data being generated over the past 2 years through his phone calls. the telecom provider refused, but then in the end, by EU court, was forced to share this data. And together with a newspaper, they produced some stunning infographics about all his passageways throughout this period that could be extracted from the information. So who owns the data is another very interesting question. And finally, what revenue model for data and data apps can be come up with? Is it revenue sharing between data providers and app developers, for example, or other? How to create an urban real-time data project. Some points to conclude with, which over the past years that we've been carrying out these projects have become interesting. First one is formulating a design vision for these projects becomes real key. I mentioned before how it works based on design-driven research and research-based design. And it's really through this design vision that enables you to bring different partners, different organizations from different disciplines together around a common goal. Second point, strategic data sharing partnerships. How can you create win-win situations between the different partners that share their data so that every partner that joins in the project understands very clearly what's the benefit in it. Talking data means talking with CEOs, I mean. And I'm saying that because data in organizations cuts through all of the departments. You might talk to the technical department, the IT department, and they might be interested in working with you, but for sure you'll get blocked by the policy department. So data is such a delicate issue for every company organization that it really needs the full buy-in into any project. Real-world data is the core actor. Keep in mind systems of the ones I've been talking about were not set up to share data. And so all the projects that I've been showing, there's a big challenge in developing these technologies that are capable of handling this data. The bus system, the subway system, telecommunication systems were not set up to share this data. And so that is one of the key factors to understand how messy is this data? How can you work with real-world data? Design vision ultimately helps to steer the project, gives the leeway to partners and data system conditions while maintaining the project on a focus. And as a last point, innovation creates pressure. We've seen it increasingly. You work with data and work on some of these projects. It can be really hard for any organization to make this innovation their own. Because working with data often creates a situation which poses organizations that they are not set up to work with this data in creative ways. And so while developing technologies, it really also requires organizational design in order to embrace the opportunities and possibilities that become possible with that. What is clear, however, is that not doing it, not working with data in any planning, management, city management, and city design project, not working with this data that's available, that's generated as a resource that exists, is like throwing away an opportunity, throwing away possibilities out of the window. One of the key elements why we've got companies and cities partner with us for our projects is that companies come to us and say, well, you know, we're generating lots of data. We're not doing much with it, and we realize we're throwing out money out of the window. So let's find out what creative ways we can use this data for the different projects. And with that, I'd like to conclude, and thank you very much for your attention.